This is why we are to like the producer and the angles of working. Okay, I consider it as I think what that made no. That's not okay. What you can take any kind of application now. Where these are not by okay. See, so you see that making having smart energy wrong going inside what is the goal one is and but it is all another people are what they have tried and a lot of applications actually relate to next slide. Yes. Now okay. So hydrogen gas purification, and biochemical. This is the cycle of the now it is more and not use and in other than next slide. Now I will go to the fast because now it is application and okay, so this is the kind of and and we are giving this reduction rate of variation by 84% and in 2019 this is next. Yes, it is important. You see, this particular case, the legal side has increased. This is regarding the actual task right. This side. This is one benefit. The second benefit. So what is accelerated legal side. And I think because another problem is then kind of so then the very side of the legal but what is the very side increase cycle and now application increase the side is means just increasing size, not the size increase, it is significantly increasing a lot. Okay, so 1% increase is a lot. Okay, so then this is the and very critical and it is only PhD and next. Multiple stages are both sides in there. They are they are used and microelectronics and so these are the doctor and they are particular but one market also it is the selective okay like it is essential category so you can write any fire and physical kind of okay. Next. This is not and then this work is used for pesticides. These are major technology pesticides. Okay. According to different grades, the need and these considerations are okay. So okay. So then pesticide and pesticide into the water and yes. Now my part is we are where so I said people here and the global report the global and yes, please come. I started with this method what is starting I and we started with the weekend and we found that the good system. But what is this so we publish two papers of the company. One is concept emergency by the law and what we are doing the teacher is another teacher is another because only everything was another ordinary so we find the way that you want. Okay, so we got the way and we got the notification of this and what is going to be there are two paragraphs. What changes are happening? See, the what changes here in first phase they are getting diagonally, in the second phase they are diagonally. Okay, and in both cases the structure will be different. Okay, in first case it will be size, in the second it will be different. So what is the this is the change. In one case, this is really important and the stuff rigid material, and the second one is diffusible flexible. And the application is like this form detects iron and mercury, and the second form detects iron and so this is really conversion and this is also this next. Yes, this is my and it is become much important to get project walks in the combining potential gene and ligand and it is usually and antibiotic. So it is basically this is last year provided and now it is also this is another kind we have the problem with this molecular biological if you are unable to get the single structure, even if you are applications are very defined and useful, people are not convinced. This is what ultimately that and often development of the structure because it is development of the structure. This is the retrofactory and but always where okay, so we after a long time we would now get this is why we are stand there and not to discuss much about next. Yes, it is nuclear retrofactory in the first two years and failure is important structure. So the activity is too high, but the problem is the structure. Yes. Yes. So we specify many of you need over and each has a very good candidate on the good and it is a calculated system and we what I can say personally I can say that we should learn the body. We should calculate at the same time. So we have calculated body position as well. And we have got different and we have also secondary and I discussed and there are we are currently two are this is a proposal form and you see the future of this is guaranteed what happening within a second. So it is a position that I and I use the so yes, it is more fun than we use for the business purpose. We will not use for the political section. We have compulsory and other people are using. So we will not so it is good to use your parents will not but this condition was very good. Heterogeneous characteristics are global expectation using this law and TS and this is my we have used electric molecule and basically we have used renewable bicarbonated system because it is very good system for carbon dioxide reduction. And carbon dioxide is the electric molecule of the reduction is highly prevalent. So we have used this molecule and I have already followed certain and it is the property like carbon dioxide and also and so this study has been completed and next, we have also developed photo effect and mechanical of the developer. So we have developed is the right method. Can I any site? Is this a very good knowledge and also business and so it will be both electrical and photo effect. So one of the slides I have maybe one of my next I will see next. Yes. This is one level 2D and LPD. So that you can see and I think in all the sections we have polymer. Because all okay. So that is so we are next and this is more this is all next. Yeah, these are my and just I will communicate one is next. RSC next. Next. Yes, good question. See, and this is because I am not looking for the flexibility. But everybody is that molecule is the same, and this is how the electrical activity and the problem is molecule was only to penetrate inside. Because it is a vast and so we use one and then water. Then not also repeat that and good water and so we it's toxicity not much and it is really good system because it is very good nothing it is difficult but I think you know right So we just see the light, so actually we are doing it. But you have to keep the fluorescent light. The light can medical certificate for the hospital. Okay. Chances are good fluorescent material is good fluorescent material. The solid state gas model the power point of the solid state is working. Okay. Now it is like so we are let's see if you are fighting for the medium then it is and my first one translates for but so this is very much but I think checking the results are upward so then any
Mic and mic.
See, you have to decide on organic in this subject and 50% of the and then add 0.1% of the just make nothing else. Then you add metal nitrate. Okay, don't get metal acetate, metal nitrate. Don't get metal chloride. Metal nitrate or metal sulfate. Add over there. Seal it for this is 24 hours, and then you will get the EPD. If EPD is not opted, your mouth is shut. I think I have to discuss this one. Okay, I am not getting your point. First thing, if you are willing to synthesize green now, then I am telling you the story. But if you have extracted from somewhere and you are adding there, so you please are sitting there and get till 2:30. Discuss this and check. Two sides are different, but different for different points. The range is around 2 to 8 nanometer, 2 to 10 nanometers. Very dense. They are all the porous material. Not medium porous. They are microporous and nanoporous. And especially, yes, it's a very good question. If you are taking a very large beaker, unnecessarily taking 3, 4, 5 kg, so they are kind of filter. एक मेटल यहाँ होगा, एक मेटल यहाँ, content your filler will be like this. So इतना इसकी length हो, so that length will decide your cavity size. So unnecessarily long linkers are not good. लंबी लकड़ी जल्दी टूटती है. So unnecessarily taking long linkers are also making the system weak. So you need to 2 to 3 kg over there and then synthesize to get a nanopore. That's all. Okay, I think thank you, sir.
Good morning, sir. My name is Anjali Patel. So my question is, what is the perfect solvent for synthesizing modes?
Well, there is nothing perfect in chemistry. See, suppose you are going for garbage sorting. Huh? There are 2000 number of solvents. Okay. Can you say that this is the perfect one for me? Huh?
No, sir.
Okay. You can say because you are one guy, you can say that this solvent is best for me. But suppose another fellow is going for the same one. Will they use the same garbage?
No,
50%
sir.
garbage. See, why I'm telling you like this. Every metal ion has different first, its oxidation state, its ionic radii, and many others. Secondly, the ligand also has good binding affinity with particular metal. जैसे मान लीजिए आपने SSAB थ्योरी तो पढ़ा होगा हार्ड सॉफ्ट एंटीबेस if you are taking hard ligand and a very soft metal the interaction will be weak and vice versa. Okay, but if you are taking hard to hard and soft interaction it will be good. Then what kind of ligand is that? If it is very much, very aromatic rings are there and the oxygen, nitrogen, hydrogens are there, they will be hydrophobic. But if there are so many electrocytes, then they are having good interaction with water and other molecules, so they will be hydrophilic. So depending upon the nature of ligand, the metal ion you are using, the resulting construction will be using the solvent. But best thing is this, because you are asking the question like this, so you always try with the water. Then do not put the toxic metal ions. Protect your environment. So methanol and all those toxic metal ions, acetonitrile, don't take it unnecessarily. Use only methanol and arene glycol. Okay, and then if required, then DMF article.
Thank you, sir. I have one more question. Sir, how do we differentiate metal complex or metal organic framework?
I have already covered it. I think.
I might miss.
Okay. Metal ions are the metal complexes are the complexes which also retain their identity when they are dissolved in any solution. But they are monomeric or dimeric or trimeric or tetrameric. Okay. But if it goes infinite, it is not. If it is infinite, not in one direction. It is infinite in X, Y, and Z, all 3D ways. Then it is not. Then see, metal complex means monomeric or dimeric unit. Then coordination polymers. Coordination polymers are different things than now. Coordination polymers means the coordination polymer को एक ribbon है जो infinite की चली जाती है. That is coordination polymer. But it is if it is going X, Y, Z direction and making gravity inside, it is.
Thank you, sir.
Good morning, sir. My name is Maharaja. My कितने डिस्टेंस से बराबर रखिए एनवायरनमेंट के लिए नैनो टेक्नोलॉजी जो एप्लीकेशन है उसका केस में टाइम लगता है this is I think different question not related to my expertise but see you can protect the environment by three ways green chemistry पढ़ा है there are 12 principles of green chemistry just go through that you unnecessarily don't use that kind of material that is having large head आपको 30% yield मिल रही 70% नहीं मिल रही that is waste so it is not environmental point of view don't use toxic solvent don't use toxic metals like lead unnecessarily using lead for the synthesis method that is toxic मैं जैसे मैंने बात बैठ करके तो 10% okay so avoid toxic things avoid such things which can cause harm to the environment try to use water as much as possible try to use copper, zinc, and these kind of metal ions which are biologically beneficial. Okay, and treat it at room temperature as much as possible. If the reaction is not happening at room temperature, heat them but if the solvent is not toxic, you can treat it as hydrogen pressure, no problem. Red water chemistry to give the molecular concept to the to know और you concept आते हैं जब भी आपको सर डिफरेंस डाउट में आपको एक तरीका बता देता हूँ आप इसमें कैसे निकालें you go and record this invisible spectrum you will get a band lowest energy band is called the whole energy lowest energy band like if it is going more than 400 nanometer also then calculate the band gap out. That is the transition gallium to 5-star transition or 5-star transition depending upon the structure of molecule. So by that we will calculate the band gap. So semiconductor में हम बोलते हैं conduction band and valence band. So valence band is below and conduction band is high. The same thing applies with the organic chemistry. The highest point molecular orbital is called as home and the lowest point molecular orbital is called blue. And the band gap is simply determined by that band heading in the universal. Clear? I'm very happy. If you are not recognized by your teachers, you are coming by yourself. It is wonderful. I was not expecting that just students are sitting over here and they will be interacting with such an efficient manner. Very nice. Please.
Good morning, sir. My name is Srini Joshi. My question: why metal nitrate is development preparation
ठीक है अच्छा metal salts metal chloride metal nitrate metal acetate metal perfluorate they all are salts but they are having some certain latitude everything is having a latitude okay and the reaction is good that is the question is less and so metal nitrate because nitrate binds the metal on monodensity and it is having like this ऐसा लगता है कि किसी को बस बाहर ले जाता है and it is having some steric graph. On the other hand, if you find both of them, so that's why I don't use metal as home temperature. And high temperature it can use, but metal nitrate automatically is made at home temperature. And the same thing happens in the furnace. But chloride, metal chloride is good living group also, but it has less steric graph. Near kind of thing, but it does not dissociate to it. It becomes the part of the chemical product, and when your process leakage of the practical purpose, the chloride dissociates, and that becomes one of the regions of the rupture of your process. And these stages happen. That's why I always avoid using chloride and acetate. Better use sulfate and or we have
all the CV projects are
and you know what if you are hesitating to come in front of me here right now although it's not a big large number you may interact with me anywhere I am sitting in the table you are most welcome जो मेरे स्टूडेंट फ्रेंड से आप पूछिए और आपसे चलते हैं ना चाय में पीते जाते जाते पर एक रुकिए क्वेश्चन पूछना है never bother about that it's very good and today I'm very happy to see that they are speaking as really in front of me it's such an honor to see okay so you can select any point of time I'll give my time I'm up to 2:30 p.m. here हिंदी तो बहुत बीच में बोल रहा हूँ बहुत अच्छी हिंदी बोलता हूँ मैं कोई दिक्कत नहीं आप हिंदी में लेक्चर कराने के लिए भी बुला लेना मुझे मैं हिंदी से हूँ मैंने जैसे तक हिंदी से पढ़ाई की है तो वो हिंदी मेरी बहुत प्रकाशन की बुक पढ़ी है मैंने ठीक है अंग्रेजी कहीं से बहुत ज्यादा तो नहीं है बाद में आ जाती है धीरे धीरे बस इससे पहले सब्जेक्ट पढ़ूंगा बढ़िया ठीक है सब्जेक्ट की नॉलेज रखना इंग्लिश अपने आप आएगी आती है और ग्रामर पे कमांड करता है जैसे पढ़ते रहना है चलिए पता मैंने किया था अपने आप ग्रामर पे कमांड ठीक है बाकी अच्छे से सब्जेक्ट पढ़िए देखो ये चीज बता रहा हूँ इस समय इंडिया का मैं मैसेज वाला हूँ इस साइंटिस्ट को एनएमआर से नोबेल प्राइज मिला था इसकी अपनी लेसन है ठीक है, और जिनके साथ रहना उनको लोग प्राइस करेंगे। आइडियाज जगह से मुताबिक नहीं होते। या सदस्य में बैठे हैं तो पहले से एक दिमाग रख लें कि भोपाल दिल्ली या बेंगलुरु वाला तो नहीं जाएगा और एक उसके बाद ऐसा कौन सा डेटा लीजिएगा। आजकल आपके पास नहीं देते हैं 1.5 जीबी डेटा बड़े अच्छे रेट में मिल रहा है, जो रोज देख सकते हैं वो आप भी देख सकते हैं। अब ये डिफरेंशिएशन नहीं रहा कि आप सदस्य में है कि बेंगलुरु, ठीक है, बेसिक एजुकेशन थोड़ा मैटर करती है, बस हार्डवेयर उसको कवर कर लेता है। ये हार्डवेयर आप आगे क्या करेंगे?
ये माइक ले लो
अब आपको हिंदी बोलने को बोलेंगे तो भाई उसको बोलेंगे।
मेरा क्वेश्चन ये है कि सर क्या एक ही प्रकार के करके विभिन्न मेटल ऑर्गेनिक मेटल ऑर्गेनिक फ्रेमवर्क बनाए जा सकते हैं?
बनाते हैं लोग। मैंने क्वेश्चन आया, देखिए एक ही जगह यूज किया, गोबर निकल का बजट सब डालते जाओ और ऐसा नहीं कि सब डालो तो एक ही चीज मिले। सब मेटल की बनावट अलग अलग होती है, यू विल गेट डिफरेंट काइंड ऑफ।
सर हमने एनएससी फाइनल के स्टूडेंट है, तो कॉपर का हमने मेटल ऑर्गेनिक फ्रेमवर्क बनाया था, तो किसी के इच्छा के साथ और कोई भी बना सकते हैं क्या स्पेशली?
मैंने बोला था टॉपिक मेटल एंड नहीं बाकी दोनों आपके लेवल पर एनएससी वाले हैं, उसकी केमिस्ट्री देखिए अलग अलग टाइप के स्ट्रक्चर से लेके बनाए, ठीक है। थैंक यू सर। राइट,
Thank you, sir. Thank you so much for enlightening us on metal organic framework, materials, features, preparation methods, modulation, designing strategies of MOS, and wide applications of MOS. And lastly, patiently solving the queries of our students and motivating the students. Now, I request Dr. Sukhdev Prasad Hariwal to present the token of memento as certificate to our speaker. तालियों की कमी हमेशा नजर रखनी इतने बड़ी लड़कियों की बात की तालियां नहीं बजाएंगे क्या? Thank you, sir. Thank you for wonderful lecture. Now, ending the session, I request Dr. Molly Thomas to introduce us with our next speaker, Dr. Shilpa Sharma ma'am. Dr. Molly, please come on stage and introduce with us Dr. Molly. Thank you, Dr. Abhinav ma'am. Here I am going to welcome Dr. Shilpa Sharma ma'am. Currently working as assistant professor in the Department of Biological Sciences and Engineering, Data in Bharat University of Technology, Rohtak. She got her scientific degree at Institute of Nanoscience and Technology, Maharaja, Punjab. She completed BTech in Biotechnology in 2008 from University School of Biotechnology, Guru Gobind Singh University, Delhi, and received a PhD degree in Nanotechnology in 2013 from Indian Institute of Technology, Guwahati, Assam. Also qualified state in 2008. Her second interest lies in the area of nanobiotechnology, particularly in the development of nanocomposites for therapeutic application, bioapplication, and tissue engineering. She has published 22 research papers, 9 book chapters, with achievement of 10. She has organized 400 lectures and invited speakers, completed 5 training projects, and attended many national and international conferences. Dr. Sharma was the recipient of previous research award and commendable research award from NSCC. Sri Vinayak M. Vishwakarma Scientist Award from Indian Kite and Kite Society for a travel grant from Department of Science and Technology in the year of 2012. She is a member of many organizations such as Indian Society of Neuromedical, Association of Microbiologists for India, Indian Kite and Kite Society, and Biosciences. Welcome, you. Am I audible? Thank you for such a good introduction. तो मैं अपना लेक्चर हिंदी इंग्लिश दोनों में कर देती हूँ और बहुत बेसिक है मैं ज़्यादा रिसर्च के बारे में नहीं बात कर रही मेरा आइडिया यहाँ पे खड़े होने का है और टॉक के बारे में ये आप मेरा ये मकसद है कि आप जान सके कि हमारे इंडियन एंशिएंट इंडियन कितने इंटेलिजेंट हैं राइट तो वो नैनो मेडिसिन आप लोग जवाब दे सकते हो क्या है नैनो मेडिसिन Ayurvedic nanomedicine. Very good. So currently we are talking about nanotechnology. Nanotechnology जो term है it's a modern term. अभी शुरू हुआ है और इसका it started with this famous talk by the renowned physicist Richard Feynman in the talk There's Plenty of Room at the Bottom in 1959. इनका nanotechnology का term जो है 1974 में खोला गया तो क्या है nanotechnology बेसिकली द कॉन्सेप्ट है कि जब भी कोई मटेरियल अपने नैनो फॉर्म में आता है दैट इज 10 टू पावर -9 मीटर उसका प्रॉपर्टीज चेंज हो जाती है इट स्टार्ट बिहेविंग एज इफ इट्स अ न्यू मटेरियल राइट जैसे गोल्ड इज अ नोबल मेटल इट इज येलो इन कलर but gold nanoparticles they are red in color. So as you change the size of the gold nanoparticles, the color is also changing. So it is gold, but it is behaving as it's a new material. When it is silver, when it comes to nanoform, it becomes yellow in color and it is highly reactive. So there are two approaches of forming nanomaterials. One is top down. आप मटेरियल को लेते हो और उसको धीरे-धीरे छोटा करते हो. And the other is bottom up. You start with the atoms and the molecules, and then you combine them and form nanomaterials. Next slide. So nanomaterials is basically application of nanotechnology in the area of healthcare. Okay? तो उसमें सबसे पहले कल हमने बात की ड्रग डिलीवरी क्योंकि नैनो पार्टिकल का साइज इतना छोटा होता है इट कैन इजीली रीच टू द सेल हमारी बॉडी में इट कैन रीच टू डिफरेंट टिश्यूज राइट एंड यू कैन टारगेट दोस नैनो पार्टिकल्स कैरिंग द ड्रग टू दैट पर्टिकुलर सेल सेकंड इज पैथोजन डिटेक्शन थर्ड इज टिश्यू इंजीनियरिंग आजकल बहुत सारे नैनो मटेरियल्स आ रहे हैं जिन पे आप अपने सेल को सीड कर सकते हो और उसमें पूरा टिश्यू डेवलप हो जाता है और उस टिश्यू को आप अपने जहाँ पे आपको जरूरत है खून की थी वहाँ पे रख दो इट विल मर्ज विद द बॉडी सो दैट इज टिश्यू इंजीनियरिंग नेक्स्ट इज ऑल्टरनेटिव एंटीमाइक्रोबियल देयर आर लॉट ऑफ नैनो मटेरियल्स व्हिच हैव एंटीबैक्टीरियल एक्टिविटी अभी कोविड में भी बहुत सारे एंटी कोविड नैनो मटेरियल्स आ तो इन्फेक्शंस को टारगेट करने के लिए यू कैन यूज नैनो मटेरियल देन बायोसेंसिंग ऑफ पैथोजेंस nanodiagnostics of infection, cancer cells in some perspective. And this is very interesting, nanometric robots. You can send these nanomaterials to your body and they can monitor what is happening inside. Next slide. Now this my topic which I was given was ancient nanomedicine. So it becomes imperative to talk about Ayurveda. Yeah. So Ayurveda is knowledge of life, है ना? और ये हमारा बहुत पुराना, सदियों पुराना, till the जब से वेदों के टाइम से ये आयुर्वेद है, राइट? और इसमें कॉन्सेप्ट ऑफ नैनो मेडिसिन, मतलब उसमें ऐसे बोला नहीं नैनो मेडिसिन, बट वो आयुर्वेद नैनो मेडिसिन का ही कॉन्सेप्ट यूज करते हैं, राइट? So ancient Indians were very intelligent. They knew how to manipulate matter at nanoscale, right? तो उसमें भले ही जो टर्म है अभी आया, लेकिन इसका कॉन्सेप्ट तब से चला, राइट? नेक्स्ट स्लाइड। तो आयुर्वेदिक नैनोमेडिसिन जो है, ये हमारा एक आयुर्वेद का पार्ट है, रस शास्त्र, which is Vedic chemistry. So it deals with herbal metals, non-metal preparations called bhasm. भस्म का नाम सुना होगा आपने, राइट? तो ये जो भस्म क्या होती है? एश किसी चीज को जब जलाते हैं, इन दी एंड प्रोडक्ट इज भस्म। तो ये भस्म बहुत सारे डिजीज कंडीशंस में यूज करते थे हमारे एंशिएंट इंडियंस, अभी भी करते हैं, राइट? और इसका कोई टॉक्सिक, कोई साइड इफेक्ट नहीं, राइट? नेक्स्ट स्लाइड। तो कैसे बनाते हैं? मिनरल और मेटल को लेते हैं, वो भी मैं आपको डिटेल में एक्सप्लेन करूं, और फिर उस प्लांट जूसेस में क्रश करते हैं, ग्राइंड करते हैं, उसको हीट करते हैं, कूल करते हैं, हीट करते हैं, कूल करते हैं, रेपिटेड हीटिंग एंड कूलिंग that eventually turns that metal and mineral into nanoparticles, और उसको हम भस्म कहते हैं, राइट? अच्छा, इसका बेसिक कॉन्सेप्ट क्या है कि जो मेटल्स एंड मिनरल्स हैं, in their natural form they are very toxic, हमारी बॉडी के लिए अच्छी नहीं, क्यों? क्योंकि वो हेवी होते हैं, नॉन एब्जॉर्बेबल है, टॉक्सिक है। लेकिन जब आप उसको आयुर्वेद के प्रोसेसिंग टेक्निक्स करते हो, उसको जलाते हो और सारे उसके साथ प्रोसेसेस करते हो, they become fit for therapeutic purposes, right? Next slide. So basically metal minerals दिया, उसको हीट किया, उसको ग्राइंड किया प्लांट जूसेस में, एंड इवेंचुअली नैनो पार्टिकल्स का फॉर्म, और यही भस्म है, राइट? तो हमारे जो साइंटिस्ट थे एंशिएंट इंडियन, दे वर वेरी पार्टिकुलर कि कैसे ये भस्म बनानी। अगर थोड़ा सा भी अगर बल्क मेटल रह गया है, तो वो भस्म को रिजेक्ट कर देते हैं। तो दे वर वेरी स्ट्रिक्ट, और ये जो रस शास्त्र है उसमें पूरी टेक्निक बताई है कि कैसे भस्म बनाना। अगर थोड़ा सा भी डिविएशन करोगे तो वो मेटल आपकी बॉडी के लिए ठीक नहीं, इट बिकम्स टॉक्सिक। तो आज साइंटिस्ट जो वेरी प्रिसाइज, दे वर वेरी इंटेलिजेंट, कितने डाउट करेंगे, कैसे करेंगे, और वो प्रॉपर भस्म हमारे शरीर के लिए अच्छी बनेगी, राइट? नेक्स्ट स्लाइड। तो ये जो आयुर्वेदिक नैनोमेडिसिन है, इसके बहुत सारे थेरेप्यूटिक यूजेस हैं, एंटी माइक्रोबियल, बैक्टीरिया के अगेंस्ट, इन्फेक्शन के अगेंस्ट है, कैंसर के अगेंस्ट काम करता है, एंटीऑक्सीडेंट है, एंटी इंफ्लेमेटरी है, और इम्यूनिटी बढ़ाता है, राइट? टारगेटेड ड्रग डिलीवरी, दीज आर ऑल एप्लीकेशंस ऑफ आयुर्वेदिक भस्म, राइट? नेक्स्ट स्लाइड। तो ये कुछ कमर्शियल भस्म है जो मार्केट में अवेलेबल है, जैसे कल मैम ने स्वर्ण भस्म के बारे में बात की थी, गोल्ड ऐश, वो आर्थराइटिस में यूज होती है। रजत भस्म, दैट इज सिल्वर ऐश, दैट इज यूज्ड फॉर रेस्पिरेटरी डिसऑर्डर। उसी तरह लोहा भस्म है, दैट इज आयरन, कंटेन्स आयरन, दैट इज नीडेड फॉर एनीमिया हो जाता है, या आपको अगर आपका एक्सेसिव फैट है उसको गिलाने के लिए। तो ये डिफरेंट इसके यूजेस हैं फॉर डिफरेंट, यू कैन हैव अ फोटोग्राफ, ये सारी साइड बेसिक है, दिस इज फॉर योर टू गेन, सो दैट यू गेन इंफॉर्मेशन अबाउट। नेक्स्ट स्लाइड। नेक्स्ट स्लाइड। So these vaccines, they are immunomodulation. Immunomodulation का मतलब है आपकी immunity को modulate करना, मतलब enhance करना, right? They are आपकी जो drugs हैं उनको particular site पे ले जाता है. They are non-toxic, easily absorbable है, digestible है, आप आसानी से खा सकते हो और बहुत कम मात्रा में cellular, right? And very rapid response, stability of a long period. So these are all characteristics of भस्म, right? Next slide. अच्छा ये भस्म कैसे बनता है? आप that I will show in the next slide. So basically, you can see this point, third point. भस्मीकरण is जो भस्म बनाने का तरीका है, right? तो जब आपका बल्क मेटल को आप जब ग्राइंड करते हो, हीट करते हो, कूल करते हो, जितने भी फार्मास्यूटिकल प्रोसेस करते हो, तो वो जो मेटल है वो अपना मेटल ऑक्साइड बन जाता है, राइट? और उस पूरे प्रोसेस में अपनी टॉक्सिसिटी को लूज कर देता है, राइट? और जो भी आपने प्लांट यूज किया, अभी मैं आगे बताऊंगी, लोग तेल का तेल करते हैं, आपका ये गाय का यूरिन यूज करते हैं, ट्रिपला यूज करते हैं, कांदी यूज करते हैं। तो जब आप उसको ग्राइंड कर रहे हो, उस प्रोसेस में पूरा का पूरा मेटल जो है वो अपनी टॉक्सिसिटी यूज कर रहा है, क्योंकि बहुत सारे प्लांट के जो एक्सट्रैक्ट है उसको कवर कर रहे हैं, राइट? So in the process, the toxicity is reduced and it becomes manageable also, right? और उस प्रोसेस में ये जो भस्म है वो इजीली आपकी बॉडी डाइजेस्ट कर रहा है, राइट? एंड देन दिस आल्सो इंक्रीज द थेरेप्यूटिक इफेक्ट, क्योंकि नैनो पार्टिकल्स का हमने पढ़ा था उनका सरफेस एरिया बहुत ज्यादा होता है, राइट? तो और बहुत छोटा साइज होता है, तो दे आर एबल टू रीच द सेल्स इन द बॉडी। तो वैसे ही भस्म काम करती है। गॉट इट? यस, नेक्स्ट स्लाइड प्लीज। ये कुछ एग्जाम्पल्स हैं ये बताने के लिए कि भस्म में आपके मोस्टली ऑक्साइड फॉर्म रहता है, जैसे आयरन, लोहा भस्म में आयरन ऑक्साइड होता है, राइट? टिन, जो टिन है उसमें टिन ऑक्साइड, राइट? नेक्स्ट स्लाइड। अब थोड़ा सा देख लेते हैं हाउ भस्म का फॉर्म। तो सबसे पहले क्या करते हो, मेटल मिनरल को लेते हो। अब आपने कहीं से उठाया है, उसमें बहुत सारी इम्प्योरिटीज होंगी, राइट? तो उसका शोधन करना जरूरी है, उसको प्यूरिफाई करना। तो कैसे करते हैं प्यूरिफाई? उसको हीट करते हैं, एकदम रेड हॉट यू हीट इट, राइट? एंड देन यू डिप देयर इनटू दिस सीसम ऑयल, बटर मिल्क, काऊ यूरिन। तो हीट किया, उसको मीडिया में डाला, हीट किया, मीडिया में डाला, हीट किया, मीडिया में डाला, ऐसे ऐसे करके कम से कम 6-7 बार करना पड़ता है। तो ये जो आयुर्वेदिक प्रोसेस है बहुत कॉम्प्लेक्स है। हम लैब में तो बहुत इजीली नैनो पार्टिकल्स बना लेते हैं, राइट? मैकेनिकल मेथड में आप बॉल मिलिंग कर दी, या केमिकल मेथड में आपने रिएक्शन किया और नैनो पार्टिकल बना दिया। लेकिन आयुर्वेद में बहुत कॉम्प्लेक्स प्रोसेसेस इन्वॉल्व है, राइट? नेक्स्ट स्लाइड। तो जब आप प्लांट करते हो तो प्लांट के अंदर बहुत ऑर्गेनिक कंपाउंड्स होते हैं जो मेटल के साथ बॉन्ड बनाते हैं, राइट? और जब आप हीट कर रहे हो, दैट इज लीडिंग टू इंक्रीज इन द टेंशन, और जो मेटल है वो एक्सपैंड कर रहा है जब आप उसको हीट कर रहे हो। फिर आप उसको तुरंत कूल कर रहे हो, इससे कंट्रैक्ट करेगा, फिर आप हीट कर रहे हो, फिर कॉन्ट्रैक्ट, ऐसे करने के चक्कर में वो ब्रिटल हो जाता है, राइट? और ब्रेक डाउन इनटू स्मॉल पार्टिकल्स, राइट? तो क्या है, कौन सी अप्रोच हुई, टॉप डाउन या बॉटम अप? टॉप डाउन, आपने बड़े मटेरियल को लिया, छोटा लिया, तो आप उसको हीट कूल, इस प्रोसेस में the material is becoming brittle and it is reducing to small particles. Yes, next slide. So इसमें क्या होता है, इस प्रोसेस में all the impurities are removed, right? कुछ there is reduction in the particle size, उसके बाद कुछ additional qualities आ जाती हैं जो आपके herbal extract से आएगी, कुछ cow urine में होगा, कुछ tripla juice में होगा, उसकी medicinal properties उस भस्म में आ जाती है, right? And it makes heterogeneous material into homogeneous material. Next slide. So these are some, you can have a photograph just to give you an information what are different Shodan procedures involved. Next slide. उसके बाद आता है भावना। तो इसमें क्या करते हैं, हर्बल जूसेस के साथ उसको ग्राइंड करेंगे, ठीक है? तो एक पेस्ट बन जाएगा एंड देन उस प्रोसेस में भी फर्दर रिडक्शन इन साइज नैनो पार्टिकल बन रहा है, राइट? एंड देन उसकी आप वो क्या करते हैं, चटनी बनाते हो, पेलेट बनाते हो और उसको हीट करते हो, दैट इज मार्ग, राइट। नेक्स्ट है, तो ये जो जितने भी स्टेप्स हैं इसमें देयर इज कंटिन्यूअस रिडक्शन इन द पार्टिकल साइज, तो वो इन दी एंड नैनो पार्टिकल बन जाता है। नेक्स्ट स्लाइड। So these are some our ancient Indians were very smart कि आपने सारे प्रोसेसेस करे और आपकी प्रतिमा बन गई, तो जरूरी नहीं कि वो हर आपकी बॉडी के लिए अच्छी है, यू नीड टू डू द क्वालिटी चेक, राइट। सो फर्स्ट चेक इज कलर जो एशियन है वो होना चाहिए, इट शुड बी डक्टेड, मेटल शाइन करता है, हर शाइन नहीं करती, तो उसका टेस्ट है कि आप सनलाइट में लेकर आपने घर में बनाई है, अगर वो शाइन कर रही है तो मतलब अभी वो बनी नहीं, तो नीड टू होल्ड इट अभी इट शुड बी वेरी लाइट, इतना फाइन होता है कि अगर आप दो फिंगर्स से उसको रब करो वो आपकी फिंगर की जो एप है उसमें जाके बैठ जाए, राइट। And then it should be smooth and should not create any irritation to your stomach, क्योंकि आप उसको खाना है, right? So it should not cause any irritation in the body. Next slide. So कोई भी मेडिसिन को अगर क्वालिफाई करना है, अगर मॉडर्न मेडिसिन में, तो it should qualify the scientific scientific analysis should be done. ये कि कुछ भी उठाया खाते, राइट। अब आयुर्वेद में क्योंकि ये चला आ रहा है सेंचुरी से, तो किसी ने क्वेश्चन नहीं किया, लेकिन जो हमारे मॉडर्न साइंटिस्ट थे और कभी कुछ टॉक्सिक इफेक्ट आ रहा है और ये प्रथा सदियों से चल रही है, बट मॉडर्न साइंटिस्ट इसको इतना इजीली लेते हैं, they don't accept it, right? Because we are scientists और हम लॉजिक देखेंगे, हम साइंटिफिक एनालिसिस करेंगे, right? तो कंटेम्पररी में जो हमारे नैनो पार्टिकल्स की जो टेक्निक है उससे जो भस्मों को एनालाइज किया, लाइक टेन हो गया, सेल हो गया, एटॉमिक स्पेक्ट्रोस्कोपी, एक्सआरटी, इंफ्रारेड स्पेक्ट्रोस्कोपी, they found that these bhasms are actually nanoparticles. Yes, next slide. तो ये थोड़ा सा just an overview, ये नोट स्वर्ण भस्म है, ये इसका 10 इंच है, the size is around 7 नैनोमीटर। नेक्स्ट स्लाइड। ये लोहा भस्म है, मैंने बताया एनीमिया के लिए। नेक्स्ट स्लाइड। नेक्स्ट स्लाइड। तो दिस इज जस्ट टू गिव यू एन ओवरव्यू, कैसे स्टार्ट करते हैं। ये आयरन के पीसेस है, ठीक है, इसको रेड हॉट किया, बर्न किया, फिर उसको डिफरेंट मीडिया में डाला, काऊ यूरिन, ट्रिपला जूस, काली, पर एक बार नहीं, साथ बार, ठीक है। And in the end, you get this form. So you started with this, and in the end, you get this form. और ये अभी नैनो पार्टिकल्स ये धीरे-धीरे छोटा होता है। नेक्स्ट स्लाइड। उसके बाद फिर से कुछ प्लांट एक्सट्रैक्ट डाले, उसको सनलाइट में रखा, उसको फिर हीट किया, फिर उसको फिर प्लांट एक्सट्रैक्ट डाला, फिर उसको हीट किया। What is heating factor? उसकी चटनियां बनाई और उसको हीट किया, राइट। नेक्स्ट स्लाइड। नेक्स्ट स्लाइड। This is after 5 heating cycles. This is after 10 heating cycles, 15 and 20. So you started with iron bulk में, और in the end you get this. और इसको जब आप माइक्रोस्कोप में देखोगे, they are nanoparticles. तो आयुर्वेद बहुत कॉम्प्लेक्स प्रोसेस है, उसमें कितना 7 बार, 21 बार, 23 बार करके you get the end product. Unlike modern nanotechnology, उसमें क्या होता है, रिएक्शन लगा नैनो पार्टिकल बनते हैं। बट आयुर्वेदिक साइंटिस्ट वर वेरी इंटेलिजेंट, अगर आप 7 की जगह 6 साइकिल कर रहे हो तो आपको नैनो फॉर्म नहीं मिलेगा, राइट। नेक्स्ट स्लाइड। So this is just this atomic absorption data of Loha plasma showing that इस पूरे प्रोसेस में there is significant reduction of the minor metal concentration. मतलब आयरन की जगह पे बाकी प्योरिटीज की वो कम होगी। नेक्स्ट स्लाइड। ये इसकी सेल इमेज है। नेक्स्ट स्लाइड। नेक्स्ट स्लाइड। दिस इज वांग भस्म, टेन की है। So you start with टेन, you do all the processes, and in the end you get milky white solution. मिल्की बाय सॉरी नेक्स्ट स्लाइड ये इमेज स्लाइड तो exactly से पता चला कि tin oxide है next slide is at 10 images the size is 20 nanometer this is all about right coming to this topic is nanomedicine तो बहुत सारे हमारे कोविड के टाइम बहुत रिसर्च हुई गोल्डन पार्टिकल सिल्वर कॉपर which were found to be effective against COVID. तो ये हाइपोथेसिस है कि हमारी भस्म में ये नैनो पार्टिकल्स है तो हो सकता है कि ये भस्म भी कोविड के अगेंस्ट काम करे बट रिसर्च इज नॉट नीडेड मोर स्टडीज आर बीइंग गोइंग ऑन नेक्स्ट स्लाइड तो ये एक पेपर है दिस इज अ वेरी रीसेंट पेपर इसमें इन्होंने देश की भस्म को हाइड्रोक्लोरोक्वीन के साथ कॉन्जुगेट किया again antivirus and they found that the cells which were infected by virus they were able to survive because of the presence of this combination so it is make next slide so this is a chapter therapy this is diamond it contains diamond and studies have been done in vivo studies also that may be studied and they found that even plasmaball could be a potential anti-cancer drug. Next slide. This is antibacterial ayurvedic nanomedicine. Antibacterial का कोई infection में हो जाता है बैक्टीरिया का, right? तो उसमें रजत है, सिल्वर की भस्म यूज हुई है और ये they have found कि effective है. Next slide. Not only silver, ताम्र भस्म, यशाकल और हड़ताल भस्म different भस्म भी effective against microorganisms. Next slide. So this is just I'm coming towards the end. Scientific जो हमें investigation में ये भी देखा गया कि भस्म में carbonaceous materials भी हैं, which makes sense also क्योंकि plant extract यूज करते हैं उसमें सब में कार्बन होता है. तो फुलरीन आपने सुना होगा बहुत सारे यहाँ केमिस्ट्री के बच्चे तो they have found कि फुलरीन भी present है hydrogenated carbons be present and they are coming from the plant extract. Next slide. This is and they have found that these have a better activity as compared to silver nanoparticles. Right? And these change in activities may be due to conjugation of silver nanoparticles. क्योंकि कार्बोनेशियस मटेरियल है ना that is adding to the therapeutic.
Me not please. Me not. सत्यम बता दो.
तो conclusion क्या है हम क्या है
ऐसी सारी मेरे पास
conclusion is that even though the term nanotechnology is new but the concept was being used by Indians since ancient times. और अभी भी रिसर्च जरूरी है जैसे एलोपैथिक मेडिसिन में एक ही क्वेश्चन आता है ना कि क्वालिटी क्या है इसकी सेम यहाँ पे भी एप्लीकेबल अगर आपने मटेरियल ठीक से यूज नहीं किया क्वालिटी का तो अगर आपने प्रोसेस फॉलो नहीं किया है तो आपको ठीक से भस्म नहीं मिलेगी तो यू हैव टू बी वेरी पर्टिकुलर ऑफ योर व्हाट यू आर डूइंग इन दैट This is all what I wanted to tell you about ancient mathematics. Any questions you have?
अभी आपने बताया
बेटा बेटा यहाँ आगे देवेंद्र
मैं देवेंद्र कुमार हूँ मेरा एक छोटा क्वेश्चन है आपसे आपने अभी बताया कि नैनो टेक्नोलॉजी का यूज हम आयुर्वेदिक में करते हैं क्या हम लोग नैनो टेक्नोलॉजी का यूज एलोपैथी मेडिसिन में कर सकते हैं
तो आजकल इतनी कमर्शियल नैनो मेडिसिन आ रही है देखो आपको बता दूं मैंने अपना रिसर्च एरिया कवर नहीं किया लेकिन बहुत सारी जो दवाइयां हैं वो कहाँ से आती है एलोपैथी में दवाइयां कहाँ से आती है क्या लगता है आपको बहुत सारे हमारे माइक्रो ऑर्गेनिजम्स हैं जो मेटाबोलाइट प्रोड्यूस करते हैं, वो रिकॉर्ड करते हैं दवाई में, है ना। तो ये जो मेटाबोलाइट्स होते हैं ये पानी में डिसॉल्व नहीं होते, लेकिन हमारी बॉडी में क्या है, ब्लड एंड जो वाटर सॉल्युबल है, तो वही चीज काम करेगी ना जो ब्लड में डिसॉल्व होगी। तो नैनो पार्टिकल्स यूज करते हैं उन दवाइयों के लिए जो पानी में डिसॉल्व नहीं होती, right? Because nano materials are soluble. You can make them soluble in water. Yeah. Any other question? Very good. You can target them. The concept is very simple. जैसे कैंसर सेल, ठीक है, कैंसर सेल के सरफेस पे कुछ मॉलिक्यूल ज्यादा मात्रा में प्रोड्यूस होते हैं एज कम्पेयर टू नॉर्मल सेल। तो अब आप अपने नैनो मटेरियल पे ऐसा रिसेप्टर लगा दो जो सिर्फ कैंसर सेल के मॉलिक्यूल को बाइंड करे, तो आपका आपने बॉडी में डाला वो ऑटोमेटिकली कैंसर सेल पे जाएगा, क्योंकि उसके ऊपर रिसेप्टर है उस मॉलिक्यूल के लिए जो कैंसर के लिए पर्टिकुलर। So you are targeting it directly to that particular site. क्योंकि उसके ऊपर जो रिसेप्टर है वो उसको बाइंड ही नहीं करेगा। अगर मान लो कैंसर सेल के ऊपर ए मॉलिक्यूल है और मैंने नैनो मटेरियल के ऊपर ऐसी एंटीबॉडी लगाई है जो सिर्फ ए पे बाइंड करती है, तो वो तो जाके ए को ही बाइंड करेगा ना। आसपास जो नॉर्मल सेल्स है उनमें ए है ही नहीं, तो कैसे बाइंड करेगा? तो यू आर टारगेटिंग इट पर्टिकुलर टू दैट एरिया। Any other question? लॉट ऑफ रिसर्च चल रही है, आप देखो ना पेपर जाके खोलो, कोई ऐसी चीज नहीं है जहाँ पे नैनो पार्टिकल है, हर जगह क्या रिसर्च। Any other question?
Wonderful lecture, madam. Topic is very interesting. Very interesting.
Actually, I should thank Dr. Molly. Even I was also not aware. फिर जब मुझे बताया गया कि मुझे इस पर टॉक देनी है, फिर मैंने थोड़ा पढ़ाई की and I found it was like amazing कि हमें तो पता ही नहीं है, हम इंडिया में रहते हैं और हम कहाँ।
हम लोग इस चीज पे प्लान कर रहे हैं कि जैसे कड़ाह है, जो चरक है, जो आयुर्वेदा जितनी भी है, let us compare straight forward compare with the ancient medical processes and the present one. मेरा कंसेप्ट थोड़ा सा इसमें था कि सर मेटल ऑक्साइड्स ले रहे हैं, फिर उसको हम मेटल में कन्वर्ट कर रहे हैं।
एक उल्टा होता है, मेटल को मेटल ऑक्साइड में बन जाता है।
तो अगर मेटल पहले जो एलिमेंटल फॉर्म से आता है आयनिक में, आयनिक के बाद वो ऑक्साइड में कन्वर्ट करें। अब प्रॉब्लम क्या आती है कि जो मेटल ऑक्साइड्स है वो सारे सॉल्युबल नहीं होते, वो पूरी बॉडी के अंदर है।
उसके सिर्फ ये नहीं है, उसके ऊपर ना प्लांट के मॉलिक्यूल्स भी हैं, ऑर्गेनिक मॉलिक्यूल।
मेरा एक कंसर्न था कि अगर हम मेटल का मतलब बायोलॉजिकल सिस्टम में जाने के बाद हमें कोई थॉट है मेटल का आयनिक फॉर्म, ऑलरेडी मेटल का कोई साल्ट है, क्योंकि हमारी बॉडी में क्लोराइड्स भी होते हैं, नाइट्रेट भी होते हैं, तो मेटल का कोई साल्ट है और हम जैसे फॉर एग्जांपल क्लोव, लौंग है, लौंग में यूरेनॉल होता है, यूरेनॉल के भी नैनो पार्टिकल होते हैं। तो हम मेटल का ऐसा किसी जो आयुर्वेदिक मेडिसिन नहीं है लेकिन नो, उसके साथ एक कॉम्बिनेशन बना के नैनो पार्टिकल बना और एफिशिएंसी चेक करें rather than going for the pure metal। तो
वो दिखाया ना मैंने एक
आपने दिखाया है,
वो रीसेंट रिसर्च वही चल रही है।
एक आपने जो दिखाया है जिसमें उन्होंने तो ये तरह का वो भी जो है नेचुरल प्रोडक्ट नहीं है जो हाइड्रोजन हमें नेचुरल प्रोडक्ट के साथ लेके अगर हम देखें तो आई थिंक
ये इमर्जिंग एरिया हाँ एक्चुअली प्रॉब्लम ये कि बाहर के लोग आयुर्वेद पे रिसर्च नहीं करते, बहुत कम लोग, और हम इंडियन उनको कॉपी करते हैं।
हम ही लीड करेंगे इस प्रोसेस को, हम ही लीड करेंगे तभी तो होगा।
ये हमें ही करना पड़ेगा क्योंकि हम देखते हैं एसीएस में बहुत चल रहा है, हम उसी का इन्वेस्टिगेट कर रहे हैं। हमारे दिमाग में ये आता ही नहीं कि जो हमारे पास जो संपत्ति है उसको यूज करें और साइंटिफिकली प्रूव करें. This is what I understood after reading doing my research on this.
It's a good topic. Thank you.
Any other questions?
मेरा नाम गौतम है. जैसे आपने भौतिक के बारे में बताया तो जैसे मिनरल और मेटल को लेके हम कोई मतलब प्रैक्टिकल करना चाहते हैं तो कौन सी
एक्चुअली ये बहुत सारे आयुर्वेदिक कॉलेजेस हैं जहाँ पे अलग से डिपार्टमेंट ऑफ ड्रग शास्त्र होते हैं. पीएचयू में है, बनारस हिंदू यूनिवर्सिटी में. इनफैक्ट बहुत सारे जो मैंने पेपर्स दिखाए हैं वो पीएचयू के साइंटिस्ट हैं. तो ऐसा नहीं कि लाभ कम है. आप कोई भी आयुर्वेदिक कॉलेज में जाए, बहुत बहुत बड़ी यूनिवर्सिटीज है, उनका एक डिपार्टमेंट है जो सिर्फ इसी में ही काम करते हैं. तो आप उधर जाके एक्सपोजर ले सकते हो. करते हैं लोग, नहीं करते हैं. ये जो मैंने आपको दिखाया वो लैब में ही काम किया है लोगों ने. बट आपको जब तक किसी ने किया नहीं हो आप अपने से रीड करके, क्योंकि वो संस्कृत में ड्रग शास्त्र आगे किसी को समझ ही नहीं आएगी. होगा, बट आई वुड सजेस्ट कि जो लोग इसमें काम करते हैं आप उनके साथ करो, क्योंकि उनका एक्सपीरियंस होता है ना. तो आप आयुर्वेद जैसे बनारस हिंदू यूनिवर्सिटी में चेक करिए, आपको बहुत सारे साइंटिस्ट मिल जाएंगे जो इसमें काम करते हैं. Thank you for listening. Enlightening sharing the knowledge of husband and all. Now I request Dr. Kamlesh Churashya ma'am to please present token of memento to our ma'am. Now I request Ms. Chhatrasal ma'am to present certificate and token of memento to Dr. Hilary Shivkumar Natarajan sir. Now I request Ms. Pooja Tiwari ma'am to please welcome Dr. Rahul Kumar Sharma sir with bouquet, flower, shawl and shrikhand. Now I request Dr. Molly Thomas to introduce our next speaker, Dr. Molly Thomas. Uh, हेलो सर, राज सर, प्लीज आप अपने आप को अनम्यूट कर दीजिए। For the next lecture, actually we are inviting by Dr. Anil Shah, Department of Chemistry, Dr. Anil Bose, University of Chhatrasal. He is joining us through online. Dr. Anil Shah is a professor of chemistry from Dr. Anil Bose, University of Chhatrasal. And he is a professor since 2019. Dr. Das has completed MSc Chemistry in 1996, followed by PhD in Chemistry in 2001 from the Department of Chemistry, Dr. Anil Bose, University. Dr. Das holds various posts in his entire career at the University, such as Chairman Council of Boston, Managing Editor of University, Journal of Science, in charge of the Department of Investigation, IQSC Coordinator of the Department, Executive Member of University, EC Member of University, Doctor Member of the Board of and Management. He is also convener of different national conferences, workshops, and seminars. His research interests include electrocyclic chemistry, drug design, molecular chemistry, and electrochemistry. He has rationally designed and synthesized compounds with known molecules. He is also working on synthesis of nanocomposites to fabricate sensors towards toxic gases using 2D jet printing technology. Sir has published 86 research papers, 14 book chapters, and he is also having 3 Indian patents. His Google Scholar citation is around 1.5 attended conferences. He chairs more than 15 national and international conferences and delivers 31 invited lectures. Dr. Raj works as a project investigator in 3 different research projects. 9 students have done PhD under his guidance. Welcome you, sir, for your lecture. Please, sir, you can say something.
हेलो हेलो हेलो
Hello. Hello. Only am I audible? हेलो। चलो ठीक है, ये हो गया फुल स्क्रीन। ठीक है, नहीं हो गया ना स्टार्ट। हेलो, I think I am audible there. So first of all, I am thankful for the organizers and especially to Dr. Modi for giving this opportunity. And I am sorry that I was not physically present there. I was eager to meet the participants there, and due to some health issues, I was not able to reach to Chhatarpur. So I am giving the presentation online. So before I start, this is many of you must be aware of Dr. Hari Singh Gaur University. This is the road which leads to the Dr. Hari Singh Gaur University. This is our founder, Sir Hari Singh, Dr. Gaur. He has devoted each and every penny to build this university. This is the main entrance door of our university, and this is our Department of Chemistry. So today I will be talking on nanomaterials, as we all are dealing with, and the topic of today's research is also nanomaterial, and our seminar is also focused on this topic. So nanomaterial, as we all know, is a versatile substance, or we can say material, which can be used as electrochemical sensor. We are using it as catalyst and also as electrode material. So I have divided the talk into 3 chapters, 3 papers which we have published. So we will be going one by one, and I will be going from very basic, what we are doing, and the students who are just on the verge of entering MSc or going for PhD, they will be benefited by the talk. So first of all, the first what I will be talking about, that we have done work on, we have synthesized nanoparticles of copper and silver, and we have used this for modification of our electrode, and this electrode has been used as sensor for detection of amlodipine. Amlodipine, as we all know, is a drug which is used for hypertension, and we have developed sensor for real-time analysis, which means we can detect amlodipine in urine, in blood sample, as well as in plasma. So as we all are aware that nanotechnology involves the construction of matter that is of nanoscale, which means 1 to 100 nanometer. And as we all are aware that nanomaterial act as simple, these are inexpensive, they are highly sensitive, and therefore they can be used as selective electrochemical sensor. We are using nanomaterial for heterogeneous catalysis. Nanomaterials can also be used as supercapacitors. Nowadays, people are preparing wound healing patches which are of nanomaterials. Nanomaterials can also be used for removal of pollutants. They are also used as energy source and also in photocatalysis. And as we are also aware that with increased environmental concern worldwide, nanomaterial have become more important and useful innovation for above mentioned applications. Now, these are nanomaterials, and where we can use, as I have told, it can be used in heterocyclic catalyst as supercapacitors,
electrode material, photocatalyst, energy source, pollutant removal, and electrochemical sensor. So nowadays, nanoparticle have drawn attention of scientists because, as we have just discussed, they are very less expensive and they have extensive application in the development of new technologies. And we can use them in each and every field, like in electronics and material science, catalyst, as well as in medicine. The development of highly efficient electrochemical sensor using nanostructure of metal and metal oxides has attracted the researcher for qualitative and quantitative analysis of organic molecules. Indeed, the employment of gold and platinum-based electrochemical sensor have shown incredible results. So mostly people are preparing electrochemical sensors which and they modifying the elect. But as we are aware, gold and platinum researchers have successfully explored alternate such as calcium doped zinc oxide material. This is very cheap. Nanosilica modified sensors. Rubidium doped titanium oxide, graphene oxide sensors. And I discussed with you how nanomaterials are characterized. So I won't go in detail. I will just let you characterized by cyclic voltammetry, by electric impedance spectroscopy, field emission scanning, electron microscope, powder XRD, transmission electron microscopy, and atomic force microscopy. Now directly we will come to our first topic, what we have done, and this is very nice thing that we have just modified electrode, and this electrode is used for, as I have told, for sensing amlodipine drug. So designing an electrochemical sensor for the promising potential application is a debonair task. However, the vital issues to make into consideration for fabrication such sensors include minimal cost, low toxicity.
सर आपकी प्रेजेंटेशन मूव नहीं कर रही.
Presentation is not moving.
Not
Hello.
moving, sir.
अभी कौन सी स्लाइड दिख रही?
First slide is.
But from here I can see it's moving. अभी?
Okay, sir, होने लगी.
Now slides are visible?
Yes, sir, visible.
So now I was talking about that what we have done, we have designed a sensor for detection of amlodipine. So designing an electrochemical sensor for promising potential application is a debonair task. However, the vital issue to take into consideration for fabrication of such sensors, we must include, it should be of minimum cost, it should have low toxicity, it should be renewable, and the potential for real-time monitoring. Herein, what we have done, we have attempted and designed and we have fabricated a multi-walled carbon nano tube. So, as you all are must be aware that nanotubes, carbon nanotubes, we have multi-walled and single-walled. So, we have taken multi-walled carbon nanotube, we have and coated it with copper nanoparticles which we have synthesized, and we have taken carbon-based electrode, and this we have fabricated on the electrode, and this electrode has been decorated with synthesized silver nanoparticles. As silver and copper, these are less toxic, readily available, and possess applicable electrochemical and photochemical catalytic properties. And we have done this experiment on Nova software control Metro Home autoclave. This is electrochemical workstation available in our lab. And this, as you all are aware that electrochemical workstation, it is 3 electrode working system. And pH we have measured. We have sonicated the multi-wall carbon nanotube and copper nanohybrid, and to effect complete dissolution of solution. The morphological characterization was of surface electrode was done on the workstation, and the XRD was done on Bruker 8 X-ray diffracto. This is the picture of the electrochemical workstation on which we are fabrication of electrochemical sensor. So what you have to do if you are preparing any sensor, you have to synthesize the material which has to be coated on the electrode. So we have synthesized, functionalized multi-wall carbon nanotube copper hybrids. So the chemical functionalization of multi-wall carbon nanotubes was carried out by dissolving in the mixture of concentrated H2SO4 and HNO3. The resulting functionalized multi-wall carbon nanotubes were separated by centrifugation at 8,000 revolutions per minute. They were washed and they were dried. Now these are the ratio which we have taken. So after taking your functionalized multi-wall carbon nanotube copper hybrid, carbon powder was taken and they were homogenized to form a paste which we call carbon paste. The paste was filled into we have taken one syringe, and into that syringe we have filled this carbon powder and your functionalized multi-wall carbon nanotube. Smoothing of electrode surface was accomplished by mechanically pressing the paste from the top and rubbing against a smooth and clean weighing paper. Now, after your syringe is ready, which has been filled with functionalized carbon nanotube and copper and nanoparticle of carbon paste electrode. So, the electrode deposition of nanoparticle film over the surface of electrode. This is an electrocatalytic process, and the growth, purity, shape, and thickness of nanofilm over electrode surface depends on the concentration of analyte, number of cyclic sweeps, and the scan rate. Here you can see eventually silver nanoparticle film was developed over the electrode surface by performing. We have done 15 consecutive cyclic sweep by cyclic voltmeter with the instrument which I have shown. The electrode was designed as silver nanoparticle functionalized over multi-wall carbon nanotube with copper nanoparticle carbon paste electrode. This was thoroughly washed and distilled and dried at room temperature. This is the, here you can see we have taken multi-wall carbon dissolved in, I have told, in nitric acid and concentrated H2SO4. This was sonicated and this was centrifuged at 8,000 revolution per minute. This is the syringe in which we have taken the carbon paste electrode and synthesized silver nanoparticles. And this is your electrode, and the red dots which you can see are on the surface. These are silver nanoparticles. Now this electrode we are using for detection of amlodipine. Now those who are from electrochemistry background or those who have studied in BSc or MSc these voltammetric procedure, they must be aware of these terms. So what we have done after the fabrication of the electrode, the required volume of stock solution of a standard and pharmaceutical sample of amlodipine drug was taken. The optimized parameters were fixed. The accumulation potential was applied at 5 millivolts, and we have done a square wave. Voltammogram was recorded on our electrochemical workstation. The X-ray diffraction of multi-walled carbon nanotube, functionalized multi-walled carbon nanotubes, and silver nanoparticles all were done. The deposition of silver nanoparticle on the multi-walled carbon nanotubes was done. The same image of multi-walled carbon nanotubes with carbon paste electrode is shown. Here you can see this is the XRD of, here you can see three graphs are there. First, this is your multi-walled carbon nanotube. Second one is for multi-walled carbon nanotubes coupled with copper nanoparticles, and third one is silver nanoparticle, multi-walled carbon nanotubes, and copper nanoparticles. This is the same image of for multi-walled carbon nanotube. This is multi-walled carbon nanotube with copper nanoparticles. This is silver nanoparticle and multi-walled carbon nanoparticle, and last one D is silver nanoparticle, multi-walled carbon nanotubes, and copper nanoparticles. Now, cyclic voltammetry characterized for the electrode the surface feature of bare and modified carbon paste electrodes was characterized by cyclic voltammetry. So I will not discuss about these peaks. Here we can directly come. Then for electrochemical impedance spectroscopy was done to invest electrode materials of bare as well as modified carbon paste electrodes. So you have to prepare two electrodes. One will be only bare, that will be consisting of carbon paste, and other will be our modified carbon paste electrode. So here you can see this is next plot of the different electrodes which we have discussed. So this here you can see the black dots. This is bare carbon paste electrode. Red one, red dots, this is for multifunctionalized carbon nanotubes with carbon paste electrode. And the last green one is silver nanoparticle, functionalized multi-walled carbon nanoparticle with copper nanoparticle and carbon paste electrode. Now, electrocatalytic voltammetric behavior of amlodipine. So what we have done, we have taken amlodipine as pure drug as well as amlodipine we have taken in urine, in blood as well as in plasma. So the electrocatalytic behavior of designed electrochemical sensor towards the voltammetric determination of amlodipine at bare as well as modified carbon paste electrode was observed by using cyclic voltammetry as well as adsorptive square wave voltammetry. So we will directly come to the graph. This is the A is cyclic voltammogram, and these are at voltammogram. So here you can see, so what graph of only bare carbon paste electrode. So those who are aware of the cyclic voltammogram, this is a whole curve. It's starting from here, it will increase, then again reversibly it will decrease and come to the origin. So all five graphs are there. A is for bare carbon paste electrode, B is for multifunctionalized multi-walled carbon nanotube as well as carbon paste electrode, and last one is our electrode which we have prepared for sensing amlodipine. Now, analytical applications. Once you have done your experiment, we have to validate it. So, analytical performance of proposed method as an analytical tool was validated by measuring peak current as a functional concentration of amlodipine by adsorptive stripping voltammogram. The accuracy and precision of proposed method at the fabricated electrode was validated by spiking with known amount. Spiking means we add known amount of pure drug in the sample and we validated that the ratio is increasing as per our amount which we have added. And the percentage recovery and percentage relative standard deviation, these also we have validated. And after your working of electrode has been validated, we come for the stability and reproducibility. Because all the data of electrochemical workstation, they are what we say the main advantage of this technique is stability and reproducibility of data. So we have done verified the stability as well as reproducibility also. This is the absorptive of so analysis of real samples. So the feasibility of our modified electrode was verified by analyzing amlodipine in real sample in human blood, serum, urine, and in pharmaceutical formulation under optimized condition. So these are the urine, some known percentage recovery. And lastly, what we have discussed in this, our result confirms that the successful development of highly sensitive, selective, and stable silver nanoparticle multi-functionalized carbon nanotube and its efficient response towards calcium channel blocker drug, that is amlodipine. Now, silver nanoparticles were successfully deposited on multi-walled carbon nanotube. Furthermore, the sensor demonstrated a linear response for amlodipine. Now, secondly, I will come to the second what that I have discussed. I will just take 10 to 15 minutes, then I will wind up. So, as we are aware that nanoparticles have large surface area and they can serve as very good catalyst. So, now what we are doing in our lab, we are synthesizing many organic compounds. And as you are aware, whenever we are synthesizing any organic compounds, we are using catalyst. So instead of using this traditional catalyst, what we are doing, we are trying to synthesize some nano particles of metal or metal oxide, and instead of using any inorganic catalyst, we are using the synthesized nanomaterials as catalyst. So the use of heterogeneous catalysts have received considerable attention due to the operational advantage such as insolubility in organic solvent as well as in water. Natural products are the main source of motivation to design and synthesize new molecule for drug development. So in our lab, we are mainly synthesizing indole and nitrogen containing heterocyclic compounds. So here I will discuss, we have synthesized 3 substituted indole, and those who are from organic chemistry, they must be very much aware that we can synthesize via Novenogel and Michael addition together. We can synthesize different varieties of indole. The nature of catalyst and solvent play a crucial role in the determination of product and its selectivity. As we are aware, indole and its derivative are known as important class of heterocyclic compounds in pharmaceutical as well as in synthetic chemistry. It is important to note that the replacement of hazardous solvents, as we are aware, nowadays people are talking about green chemistry, because what we chemists are doing, we are taking many types of solvents, and these solvents are hazardous to the environment as well as to the person who is working in the lab. So therefore, we have to be very much aware that instead of using these hazardous solvent, we are moving towards green chemistry. And what we are trying to do today, we are trying that instead of using solvents, we must go for the universal solvent, that is water. So in many of our reaction, I will be showing that instead of taking these solvents, we have done the reaction in water. So therefore, the use of nanomaterial as a catalyst is more greener compared from conventional catalysts, since they have much more surface area. So what we have done, this is very simple reaction. You can take aldehyde. This is one pot reaction. You have our facial one pot synthesis of novel 2,1H indole 3-methyl 5,5-dimethyl cyclohexane 1,3-dione. We have synthesized, and what we have done, instead of taking any inorganic catalyst, we have synthesized mesoporous copper oxide. This is a reusable heterogeneous catalyst, and instead of using any solvent, we have taken water. So the anti-tubercular nature of synthesized compounds were determined, and all the series of this compound was synthesized, and they are anti-TB compounds, and we have gone for their anti-tubercular activity also. So green mesoporous copper oxide catalyst, one pot, 3-component reaction. Here you can see, you can take aldehyde, choice is yours. Any aldehyde you can take, indole, you can take pure indole or any substituent of indole, and you have to take dimidone. So we have taken these three in a single pot, and we call it one pot, 3-component reaction. So a simple and efficient protocol for the synthesis of, this is the second reaction we have done. We have synthesized diindole 1-oxyindole derivatives in the presence of graphene oxide. Here you can see, instead of taking inorganic catalyst, we have taken just graphene oxide, and again we have taken water as solvent. And these reactions have been done at room temperature. So graphene oxide, a water-soluble material with a honeycomb structure. You all are aware about graphene oxide. It has a honeycomb structure. It has sp2, sp3 structure in 2D building stone, and this is, you have seen this in fullerene and nanotubes. So this is the second reaction which we have done in our lab. Again, we have done hydroanimination of alkene. It is easily performed under gold catalysis. So moreover, the heterogeneous catalysis allows an easy recycling of catalyst. And the beauty of this reaction is your catalyst can be used 10 to 15 times again without any loss in its activity. Thus, commercial gold nanoparticle. So what we have done here, we have taken gold nanoparticles and we have supported it with titanium oxide. And we have synthesized 2 aryl indoles. You can prepare a series of this compound by just taking, you have to do hydroanimation of alkenes. So this is another one pot 2-step synthesis. Again, we have supported gold nanoparticles. In the first step, you can see we have taken here you can see synthesis of some noble indoles via one pot reaction of, here we have taken reaction we have done with oxide, zinc oxide nanorods. Again, here the reaction is solvent free. You need not to take any hazardous solvent. The reaction can be done in water, and the reaction has been done at 80 degrees centigrade. So this is another example of nano zinc oxide catalyzed multi-component one pot synthesis of novel spiroindolene pyroxidone. So here we have taken, you can take indole, you can take melanonitrile, and you can prepare variety of series of these compound, and the catalyst you can use is zinc oxide nanoparticles. Now for synthesis, as I have told, you have to be aware that instead of taking any inorganic catalyst, you have to prepare or you have to go for literature कि which type of nanoparticle of the metals can be used. So once we have prepared, now I am talking about the first thing which we have done, mesoporous copper oxide. So this is FTIR, result of synthesize our nanoparticle of copper. This is XRD pattern of macroporous copper oxide monolith which we have synthesized. This is EDX. This is SAM images of macroporous copper oxide monolith synthesized. Now we have reported here an efficient green and general method for synthesis of spiroxyindole. And we have verified this synthesis by electrochemical study also. And electrochemical study revealed that the synthesized compounds are electroactive. This new process can open an efficient and convenient multi-component method to create substituted spiroxyindole, the pharmacologically active substance with known spasmolytic, diuretic, anticoagulant, anti-cancer, and in many other activities. Now, if time is there, I can continue, Molly. And as I was saying, the beauty of these reactions are, these reactions, the catalyst which you are using, so I think my time. Hello.
Thank you, sir. Thank you for your valuable talk on nanoparticles. Now, I take opportunity to introduce our next speaker, Dr. Subramaniam Natarajan. Dr. Subramaniam Natarajan is currently serving as assistant professor at Maharaja University, Tokyo, Japan, specializing in sustainable technology with a focus on recycling materials from spent lithium-ion batteries for energy storage applications, such as batteries and superconductors. He holds a PhD in chemistry from Maharaja University, CSIR, Gujarat, India. Dr. Natarajan has authored 36 publications. Dr. Natarajan has also been granted 2 Indian patents for processes related to e-waste recycling. His research
Yes,
has been
miss.
recognized
Hello.
through prestigious fellowships, including the GSPL Postdoctoral Fellowship in Japan and the Korea Research Fellowship in South Korea. His research interests includes the recycling of materials from spent lithium-ion batteries and their reuse in electrochemical energy storage and conversion applications. Dr. Natarajan gave a talk on nanotechnology in action, graphite from spent lithium-ion batteries for high-capacity graphite. Sir, welcome, sir. You can give your talk, sir.
अनम्यूट नहीं हुआ है क्या? वो देखो जरा।
वो स्टार्ट करें तब।
अच्छा ठीक है,
वो होगा।
ठीक है start करो।
All done there.
ये वहाँ आवाज क्यों?
बोलना आवाज बोल दूंगा।
आवाज कनेक्टेड उसको स्क्रीन पे करना, उसको स्क्रीन पे करना, उसको स्क्रीन
Can we use pointer? No, not. Okay.
voice is coming for you.
Voice is coming. Actually,
Yeah, your slide actually I will run. You just carry on with your, and you just tell me next or something. Okay.
okay. No,
Yeah, it's visible for you. Actually,
that-
I'm sharing the screen.
it is not.
देखेंगे ना रिकॉर्ड में तुम्हारे नहीं, रुको चलिए 2 मिनट रुको यार, पूरी विंडो कर दे रहे हैं ना। पावर पॉइंट पीडीएफ, ये वाला है, ये पीडीएफ है। कनेक्ट हो रहा है क्या हो रहा है? हम सब भी रखेंगे, हम लोगों में से कल छुट्टी है, आज को छोड़ा कहाँ जा रहा है आगे? आगे कैसे जाएगा? 11 बजे दिल्ली स्लाइड दिख रही है और मैं रन कैसे करूंगी?
Now actually it is. Yeah, I can see.
Right?
Yeah, it's okay now. I can see. I think.
हाँ पूजा।
Shall I start? Yeah. Good afternoon to everyone. Today I'm going to present in the seminar about the recycling of waste lithium-ion batteries for reuse in again lithium-ion batteries. So before that, I would like to start with some introduction about the lithium-ion batteries. So the next slide. Yeah. We know that the use of lithium-ion battery in various applications, especially in consumer electronics, every day in our life, we are using it in mobile phone, laptops, and digital cameras. Also in electric vehicles, nowadays the usage of batteries in vehicles is increased, and it will increase every year to avoid the oil-based fuels in the future. So also the usage of lithium-ion batteries in renewable energy like solar and wind and the electricity grid increasing its demand every year. So we know that lithium-ion battery is composed of cathode, anode, electrolyte, and separator. So the cathode is mainly lithium-based metal oxide with conductive additive and binder, and it will be made as a slurry and it will be pasted on the aluminum current collector foil. As you can see from this figure, the lithium-based metal oxide, either lithium cobalt oxide, lithium manganese oxide, lithium iron phosphate, lithium nickel manganese cobalt oxide, or lithium nickel cobalt aluminum oxide on aluminum current collector. So the anode is will be the graphite based on copper current collector. So similarly, like cathode material, the anode part is the graphite based will be pasted on copper current collector. The separator is will be polypropylene, polyethylene, or the combination of polypropylene, polyethylene, or polypropylene. So the binder will be mostly PVDF, and the electrolyte will be in lithium hexafluorophosphate in carbon-based solvents. So from this slide, we can get the information about how lithium-ion batteries is made. As said earlier, it is mainly composed of cathode, anode, electrolyte, and separator. And the cathode, I already mentioned that either the five cathodes which is mentioned in the slide will be the most commercialized available batteries in the market. So the next slide, please. Yeah. So due to various applications of lithium-ion batteries, the global demand for lithium-ion batteries is expected to increase to 3,100 gigawatt hour by 2030. We seen the number of applications for lithium-ion batteries in the previous slide. So from the graph, you can see the global demand, how much it will increase in the future. Also, the below figure, you can see from the total material cost dollar per kilowatt hour. There are, as I said earlier, there are a number of different chemistries of lithium-ion batteries available in the market. So the cost will increase in the upcoming year. That indicates that automatically upsurge the price of the raw materials. So the raw materials mainly for the battery production for the cathode side, it would be mostly lithium, nickel, cobalt, manganese, and the anode part, graphite, and the separator part. So the raw materials, metals like lithium, cobalt, nickel are mostly so far mined on particular countries. So for lithium, you can see from that figure, the Australia is dominated. So far by 2022, around 50% is mined from only Australia. For cobalt, the Congo, around 70% given to the world. So we can understand the importance of raw materials for the lithium-ion battery production from this figure. Also, the world resource for lithium, cobalt, and nickel is available, as I mentioned earlier. It will be mostly depending upon some other countries only. For nickel, it is mostly depending upon Indonesia only. So this graph ensures we have to depend on some critical raw materials for particular regions or countries. But we are depending on some other countries, so the cost also increasing every year. So next slide, please. So before that, we have to understand why lithium-ion batteries becomes waste. And as mentioned earlier, the lithium-ion battery is composed of cathode, anode, and separator. This is the diagram illustrates how battery is degrading during charging and discharging cycles. We can see from the cathode side, it is due to number of factors. So because of lithium-ion's movement between the cathode and anode, the electrolyte decomposition will occur and the lithium plating and dendrite formation will occur on the separator. Also, the metals in the cathode part will dissolute in the battery so that the particle will also crack. Eventually, the structure will be disordered in both sides. So that becomes the lithium-ion battery becomes waste. Also, the lifetime of lithium-ion battery in smaller electronics is only about 3 to 5 years, especially when we are using the battery in mobile phone and laptop. We can see only we will use it only for 3 to 5 years. After that we will use a new battery, but in electric vehicles it will be around 5 to 10 years. So because the number of cells will be packed as a cell, so it will be used in electric vehicles. So from the right side figure on the top, you can see the estimated lithium ion battery waste in tons. It is predicted that 2030 around 11 million tons of spent lithium batteries will be generated due to the more usage in number of applications, especially in consumer electronics and electric vehicles. So the below figure about the environmental impact of spent lithium and battery disposal. So mostly currently in India and other number of mostly the batteries will be disposed after its usage, mostly into soil or ground. If it is disposed in soil and groundwater, it will affect the human body, also animals and other plants due to its metals like cobalt, lithium, and nickel. So this number of factors emphasizing to recycle the spent lithium-ion batteries. Also, the raw materials cost also will emphasize to recycle the spent lithium-ion batteries. So, next slide. So, in industry, in worldwide, there are three type of methodologies are being used to recycle the spent lithium-ion batteries. One is the pyrometallurgy method. On the left side of the figure, you can see pyro, hydro, and direct. In pyrometallurgy method, the batteries are introduced, batteries are crushed, and some charcoal with slag agents are introduced for the smelting process. So around above 1500 degrees Celsius, the metals, all metals in the batteries will be smelted, and it will emit the hazardous gases also. Then finally the metals will be refined, especially cobalt only refined from this process, and it will be converted as a alloy. But for the hydrometallurgy method, you can see there are acids, some inorganic acids like hydrochloric acid or sulfuric acid will be used with some other oxidizing agent like hydrogen peroxide to leach out the metals, and finally it will be precipitated out and extracted for the battery production. Regarding direct recycling methodology, the electrodes will be recovered from the spent battery and it will be mixed with the lithium source, and it will be annealed to regenerate as a cathode material, and eventually it will be assembled for the battery production. So among three methods, the direct recycling methodology is the best one, because the pyrometallurgy uses high temperature and it is considered as a pollution risk, as well as loss of metals also will be included in this methodology. But hydrometallurgy is somewhat better than the pyrometallurgy method, but it is also complex and costly due to usage of acids and other chemicals. The more water consumption also will be occurred. So among these three methods, the direct methodology will be the better one for the recycling of spent lithium-ion batteries. So from the table, we can see the number of countries involved in the recycling of spent lithium-ion batteries. For example, most in Japan, the Sumitomo company is recycling the spent lithium-ion batteries around 150 150 tons annually. But this company uses both hydro and pyrometallurgy only to recover the cobalt as a cobalt oxide. Not other metals are recovered. Also, the graphite part also not recovered in all these companies. So it indicates the importance of recovery of all metals, including graphite. Next slide. So here, how we are going to use this spent graphite from waste lithium-ion batteries again for again for lithium-ion batteries using CNT, carbon nanotubes based anodes. So the next slide, please. So the objectives of the work is the recovery of lithium from spent graphite and regeneration to reuse in lithium-ion battery. And the objective 2 is to fabricate the graphite anode with the carbon nanotubes as a current collector, binder, and a conductive additive. You can see from the figure objective 1, the lithium ions will, during charging process, lithium ion will travel from the cathode to the anode part, and during discharging process, it will travel from the anode to cathode part. So what will happen during charging and discharging process? The solid electrolyte interface will form. The solid electrolyte interface will consist of number of lithium salts. As you can see from this figure, it might be lithium alkoxides, lithium carbonate, lithium oxide, lithium fluoride, or other hydrocarbon related lithium compounds. So what will happen after long-term charging discharging process? The graphite particle also will get cracked. Also, the sum of residual lithium will be stored in the anode side. Sometimes it will be stored on the anode graphite, so that the performance of the graphite also will be reduced after some time. So this residual lithium also should be recovered due to its high cost of lithium, as we seen in the earlier slides. Also, the solid electrolyte interface containing lithium compounds also should be recovered. So this is the first objective of this work. And the second objective of the work is in conventional method. No, before slide. So in objective 2,